Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 13 of JEE Advanced 2014 Physics paper 1. So we have so far discussed about 12 questions. Now let us move to question number 13. Students, let us solve the question number 13 of 2014 paper. Now it says a uniform circular disc of mass is a disc of mass 1.5 kg and radius 0.5 meter. So that is a disc here whose mass is 1.5 kilogram and radius is 0.5 meter. Is initially at rest on a horizontal frictionless surface, so it is on a surface which is frictionless. Three forces of equal magnitude 0.5 Newton are applied simultaneously. You can see here the forces are applied along this direction, along this direction, along this direction. Three sides of equilateral triangle XYZ. So XYZ is a triangle like so. X, Y and Z. This is an equilateral triangle. So in equilateral triangle, this angle will be 60 degree each. With its vertices on the perimeter of the disc. So this is the perimeter, the outer part, and the triangle vertices is touching the perimeter. 1 second after applying the forces, the angular speed of the disc in radian per second is. So you have to find the angular speed or angular velocity of the disc after time t equals to 1 second. This is the question. Now we have forces as in questions given are applied in this sense. If the disc rotates about this point, suppose O, this has to be, this force will about this point, this force F will rotate the disc in clockwise sense. This force will also rotate the disc in clockwise sense. This is also rotated in anti-clockwise sense. All of these will rotate the disc in anti-clockwise sense. So if it is in anti-clockwise sense, then the torque, because the symmetry, the forces are placed at equidistance from this point. So the torque due to any one force must be similar to torque due to any other two forces. So the torque due to, so you have to find the net torque first. Now what is the net torque acting in the disc? If I see the point, this point, then our aim is to find the torque due to any one force, and that is the torque due to other forces also. So the net torque you have to find the torque due to each forces, which will be 3 times the torque due to each forces. This is the torque due to individual forces. And to find the torque due to individual forces, we know that this distance I have to find out. If I don't find this distance, perpendicular distance on that, if I don't find the perpendicular distance, I will do this way. About this, this is my r vector. This is my r vector. R with respect to this point O. This is the force at this point. And this is the line of action of this r vector. So this is the angle between the r vector and f vector. Now because this is equilateral triangle, so this angle is 60, and this will divide it will bisect, this r bisects the angle, so it will be 30, and this is 30, so this will also be 30. So theta is coming out to be 30. If theta is 30, then the torque will be r cross f, and due to any one force is r with respect to the center of the disk, center of mass of the disk, into cross product f, that is, if I write the magnitude of that, then that is r naught f sine theta, where theta is the angle between these two vectors, which is 30 degree. If I substitute that, r naught is given, r naught is how much? R naught is given 0.5, because that will be the radius. Force is 0.5, sine theta is also sine 30 is half, that is also 0.5, so it is 1 by 2, 1 by 2, 1 by 2, it is 1 by 8. So the torque due to any one force is 1 by 8. If I see the torque due to the other force, this also will have the same situation. This is the r vector, and this angle also will be 30. Again it is r cross f, the similar situation, and this will rotate this force will rotate the disc in this sense. This force also rotate the disc in this sense. This force also, if I see here, this is r and this is theta. This is also, this is r, and this will rotate the disc in this sense also. And whatever is the torque due to the first force, the same is for the second and third. That's why we have written net torque is 3 times the individual torque. So the net torque equals to 3 by 8 in terms of magnitude and Newton meter. So we have got the net torque which is responsible for the rotation of the disc. Now that net torque, we already know that net torque is I alpha net. So we have to find that I to get alpha net, to get the angular acceleration that is produced due to the application of 3 simultaneous forces at such fashions. So we have to find the alpha net. To find alpha net, we have to find I. So alpha net equals to total net torque acting divided by the moment of inertia. This is the moment of inertia. For a disk, the moment of inertia about an axis passing through the center and perpendicular to its plane is half mr square. Half mr square. So that I equals to half, mass is 0.5 kg, is half, radius is half, square is 1 by 4. So is 1 by 16 kilogram meter square. This is the value of I we are getting here. Substituting the value of I in this equation, we have alpha net. Net torque we are getting, we got 3 by 8. This is 3 by 8 divided by that I, moment of inertia, I got 1 over 16. So it is 3 divided by 8, 16, 8 2 the 16, 3 to the 6. So 3 by 8, 1 by 16, 1 2 to the 4, 4 the 16, 1 by 16, 3 by 8, 3 to the 6, 3. So it is 6 radian per second square. So as you can see from the question, so we have to find the angular speed. Okay, we got alpha, and I is in the found this mass is actually 1.5 kilogram. We have substitute mass as 1 by 2 kilogram. So this is actually 3 by 2. So this is 3 by 16. So it is 3 by 16. Mass you can see here is 1.5 kilogram. So it will be divided by 3 and divided by 3. So it will be 2 radian per second square. So the alpha net comes out to be 2 radian per second square. Just we have substituted the value of AM as 3 by 2, which is given in the question, not 1 by 2. I firstly took 1 by 2, but it is 3 by 2. Just have to put that value. Otherwise, the method is okay. Now, as we have got alpha we got as 2 radian per second square. That means starting with the disk was at rest, initially it was at rest, and after 1 second, and we are giving at time t equals to 0, we are imparting 2 radian per second square to this. Then after time t equals to 1 second, this will rotate, and obviously it will rotate. This will rotate by whatever is the value of that omega. So omega after 1 second is omega naught plus alpha t. This is how you find the omega after 1 second. So this is omega naught, initially it was 0 because we are not rotating, plus alpha we got 2, and the time t equals to 1 second given. So that is equal to 2 radian per second. If the question is to find the what is the omega after 3 seconds, suppose what is omega after 3 seconds, the answer will be 2 into 3, that is 6 radian per second. But according to our question, it is asked to find the angular speed of the disk in radian per second 1 second after the forces are applied, just after 1 second. So after 1 second we are getting 2 radian per second. So 2 is the integer answer. So answer to this question equals to 2. This is the answer, 2 radian per second. Okay, thank you.